Hey guys, I'm Leo Mendez and today I have a new video. I got on my mesa de prueba the Cobalt 8 from Modal Electronics, a synthesizer that has a pretty interesting type of synthesis that we have rarely talked in my channel. This Cobalt 8 is a virtual analog synthesizer, and that means that the digital oscillators recreate the characteristics of analog synthesis. So, if you want to learn more, acompáñenme a ver el siguiente video. In my opinion, sound design is pretty similar to drawing. First, you have to learn the structure, the parts of the body, and then you can achieve a much more artistic interpretation. A sound that truly expresses sensations and feelings, it's hard to achieve, the same way that it's hard to draw. By this I mean that the space bells sound does not really sound like bells in space, in the same way that this nude from La Toile doesn't really look like a real nude. Both are artistic interpretations, so we need to focus on the structural elements to evoke reality. The structure of an analog synthesizer includes oscillators, filters, envelopes, and some others also have effects and modulators. These structural bones are the elements that allows us to create space bells as well as guitar sync sounds. On the oscillator section, we have two oscillators, each with 34 algorithms of analog virtual synthesis. Also, we have a mixer section that allows us to define which of the two oscillators we are going to use. Let's load the patch. In this case, it will be a string sound, and we're going to analyze which are the algorithms that build the structure of the sound. But first, let's audition this patch. On the algorithm 1, we notice that we have a square waveform oscillator, and we can also synchronize it in a more complex way. On the algorithm number 2, we can find a sine waveform that is constantly moving. The mix is leaning towards to the algorithm number 1, the square waveform oscillator. And then let's audition the oscillator number 2. As we can hear, the structure of this sound does not make sense until we balance both algorithms. And certainly, this makes me think on the strings in a guitar. When we pick a string, we can hear many harmonics, and as it relaxes, they become sine waveforms. And now, this sound structure makes perfect sense. Completely to the right, we have a sine waveform. And completely to the left, we have a waveform with a lot of harmonic content. And as we find the balance, we can hear the string. The next structural element is the filter. With this, we can remove the harmonic content generated by the oscillator algorithms. In this case, we're using a low-pass filter, as we can see on the graph. Also, we have resonance that plays a main role since it allows us to emphasize a portion of the sound spectrum. When using filters, timing is really important. When we pick the string, it reaches the maximum level of excitement, and in this moment we have a lot of harmonic content. As these forces decrease, the harmonic content also decreases. Something pretty similar is happening to the patch. To achieve this movement through time, we have the envelope generator. In terms of amplification, the attack of a string is quite sudden and pretty quickly reaches the silent section. This generates the percussive sensation of this patch. At the same time, we also have an envelope associated with the filter, and in this graph we can see its structure. In the beginning, as in the real strings, there's no harmonic removal. On the decay, there is removal of harmonics, and after the release section, the harmonics are completely removed. And this is exactly what happens in a regular string. But of course, this patch is an artistic interpretation, and maybe in this Cobalt 8 we do not have enough envelopes, oscillators or modulators to create a real string. But with the elements that we have, we can get really close, and for me, this sounds spectacular. Finally, to define the structure of the sound, we must place it in a physical space. There is no sound in a vacuum, and of course, in this Cobalt 8, we have tools and effects to create a space. For example, in the effect number 1, we can add reverb. Let's increase the mix. Now let's increase the time. And finally, the reverb size. Of course, we can also define the effect volume. And now, let's add some modulation on the effect number 3, in this case, a phaser. Finally, we can add delay to bring the patch to a much wider stereo field. Of course, once we have the skeleton and the structure of the sound, we can modulate it so it has animation over time. We can achieve this with the LFO section. For example, we can assign the LFO to the mixer, and in that way we will have movement between the two algorithms. In this way, we will be able to listen to the square waveform and also to the sine waveform over time. The Cobalt 8 is an excellent sound design tool. It has all the structural elements to generate an excellent sound. Also has an arpeggiator, a built-in sequencer, and effects, but the cherry on the cake is the size of its keys. This little detail of irregular size keys in such a small chassis puts the Cobalt 8 ahead of other synthesizers of the same price and the same range. So, I'm really liking this amazing synth. Finally, in sound design, as well as in figure drawing, we need to learn the structure and practice. Yo soy Leo Méndez y nos vemos a la próxima.